So I'm going to be teaching about Git and GitHub today, which are what are called version control systems. So a version control system is, in a nutshell, tracking the changes and the history and everything that's happened with a folder. So usually that folder is like a project, like a programming project that has, you would have like source code. So it's like a website or something, and then you have in your website the HTML pages, maybe some image files or something like that. And that for each change you make to your website, you can store that change in this version control. So there are a couple large benefits of doing that. One is that if you're working on like a team project, meaning you have multiple members on different computers and they're all working on the same project, you can all make changes to this program or website or anything, and then all of your changes aren't going to get overwritten by each other, because at each stage the version control system, in this case Git, keeps track of it and then hopefully gracefully merges all of your changes together. On the other end of the spectrum, if you say use like Dropbox to do this, where Dropbox tries to, every time you save your document, it uploads it to the server, and then say you had like another team member downloading from the server on the other end. But then what if both of you make a change at the same time? Like, you don't really know what's going to happen, and in some cases the file just gets corrupted, and then you have to revert back to the previous version, which is obviously not good. I guess I'll just jump into Git with that. So this is called a terminal window or a command line. If you're running Linux, which you'll usually have to install onto your computer yourself, which can or cannot be simple, depending on your computer and how things go. But if you have a Mac, this should be like terminal, should be built in. And if you have a Windows computer, then there's a program you can install that you'll be able to do everything that we do today. So basically, terminal lets you do things by typing that you would otherwise do by like clicking. So you have like Explorer for files, like this, where you can see like all of these folders you've made for different projects you have, like copy and paste or cut or make new files even. But for today, let's just look at the cSplash folder. So right now, in terminal, I'm at /home/Tyler. So if we look in here, this is just the root. It's like C://. So if you go home, Tyler, and then this is where we are. So we can run this ls command that lists everything in this current directory. So if we run this, we should see a list of all of these files and directories or folders, which we do. So we want to go to code. Now this cd command right here is just change directory, meaning we're going to go from home Tyler and change directory into home Tyler code. So if we run that, and then we look again, we can see we're in that new folder. So let's do that again into this one. Okay, so then now, all we have in here is this to-do file. And we can see that with ls again. So, if you wanted to see what exactly is in that to-do file, or this, this file right here, there's a command called cat, and that will list the, print out all of the contents of that file for text files. So, things that we want to cover today are terminal/command line, basic commands like I've shown you, like ls and cd and even cat. The definition of repository, version control I already gave you an intro to. Commit and branch are good. They are Git terms that I'll give you an introduction to before we start talking about the actual Git commands. And then we'll talk about GitHub and things that gives you and you're able to do with GitHub and the benefits of using it and reasons to use it. Yeah. So we'll start with repository. Repository is basically a folder that you're going to put things into that you're going to run version control. Does that make sense? It's a folder that you're going to store those files and images. And all of those files or objects are going to be in your version control system. In other words,
behind it.
Alright, so let's say you have a folder. And you have files in here, let's say, maybe another directory, and stuff to just fill in this outer folder right here. If you wanted to put this into version control, then you basically add just another folder in here for Git. And so then this is going to be your Git folder. And in this place right here keeps track of all of the changes you make everywhere else. So, once you add this in here and you're keeping track of these changes, then this directory as a whole becomes your repository. So on GitHub, when we talk about it later, you can create a new repository or fork a repository, push and pull and so on. And so people might say repo, which is just shorthand for repository. So then at each stage in your version control for Git, you're going to have a snapshot of all of the files at that time. Meaning, you could say, I want to go back to the very beginning of my project before I make any changes, and you can just look around at your code then, and then you can come all the way back to current time, which is the most up-to-date thing, or anywhere in between. Or a large benefit is, let's say you're running or you're making this program, you're coding, and other people are making changes, and then all of a sudden something is broken. And you don't know why or where it came in. You can go back to a previous version of your program that didn't have that same bug, and then try and figure out what changes were made, and that'll help you debug, find it, and fix the problem, and make those changes. So, every time you want to take a snapshot of your files and everything that's changed so far, you do one of these things called a commit. So what Git is going to end up looking like is, at the very beginning, you have just one snapshot of all of your files. And then as you make commits, you're going to get new snapshots. Meaning this is like commit number 1, commit number 2, and so on. So at every point here, it's storing all of the changes from each state. So then if you say, I want to go back to this point, it just undoes all of those changes. Is that any questions? Okay. So when you do a branch in Git, normally your timeline looks like this, but let's say you have another team member that's going to work on it at the same time, and you don't want to combine all of your changes at once. Maybe you'll do that once your new feature is a little more robust or actually working, you know? So what you can do is, at any point here, you can branch off of the another branch, and then start working again and doing commits on that branch. So that means changes you do here, commits you do here, aren't going to impact commits you do here. And then later, when you're done with these changes, and maybe you have multiple in here, you can what's called merge those changes back into your main, what's called master branch. So you would say, this is your master right here. And then when you do this, you create a new branch, and let's just call it, like, we could say, new branch. And then once you do this, you're just merging those changes into master, meaning you merge the changes you made in new branch into master. So maybe it'll be better if we actually do an example of this. So the way you start a new Git repository is you say git init. So this says initialize empty Git repository in home Tyler code cSplash.git. So our folder just started out as the cSplash directory, and then we added this .git folder into it. So if we want to look at what exactly is inside that folder, we can call another command called tree. Okay, never mind. But the thing is, with bash systems, files or folders that start with a period are hidden. So it's kind of like maybe a $sign in other systems, but if we do this ls -a, that shows us everything. And then we see this Git directory right here. And you can also see that I'm running a terminal program called zsh. And that conveniently lets us know that we're inside a Git repository right here. And then the current branch I'm on, which is master, meaning like your base, your main channel for all of your changes. And so just to get a like the current status of your repository, there's a command called git status. So all of your git commands are going to start with git, and then you're going to pass any options or commands that you have to it. So you make the git command and you pass the status command, or the status keyword to git. So then what that does is it comes back with all of this information about any changes that have happened so far. So you can see we're on branch master, which we've had the initial commit, which means we're at just that first box. And then we have what are called untracked files. So our only untracked file is to do, which you can see is in our folder here. So the way we're going to tell Git to actually see those changes that we make to a file, like to do, or to make sure it keeps track of it, is by running this git add file name, and you can add as many files as you want. So you can see nothing added to commit, but untracked files present. Meaning, if we were to do a commit right now, we wouldn't actually be changing anything because we haven't added any of our files. So we can run the command it's saying, which is git add to do. And then if we run git status again, look at this. If we run git status again, we see this new file to do. So now this means, now that we've added this file to the repository, when we make a commit, it will see all of those changes to do that we've made so far. So, alright, so now we can make our first commit. So that, surprisingly, is just git, or not surprisingly, git commit, and then you're going to pass other options to this. So for every time you make one of these commits, commit number 1 and 2 and so on, you're going to add a message, which is just like a brief comment of the changes you made or any new features you have, maybe a bug you fixed. So that way, you can look back on your repository later and see all of those changes. And you're not looking at just like number 1, number 2, number 3, or other random things. You get these nice messages. Alright, and so the way you would do that message is you do -m, and then whatever you want your message to be, you put inside these double quotes, and then when we hit enter, so with Bash, when you do the exclamation point, you have to what's called escape it, meaning put a backslash in front of it, so that it doesn't interpret the exclamation point as a keyword or another special command. So if we do backslash, all right. Now we get this it returns to us master, which means we're on the branch master. Root commit, it's our first one. This number right here, 2207AE3, that will be, every time we make a commit, Git is going to make this unique number that we can use to reference that commit. So we can't use just like 1, 2, 3, and so on, because what happens when other people make those commits, or we make branches or something like that, and we try to merge them all together, and then the 1, 2s, and 3s all overlap. So instead, we get these unique numbers right here that we can then later use to reference this commit, like if we wanted to check out the state of our program at that time. Does that make sense? Question?
I have a question. Whenever I commit, I use git commit -a-m.
Okay.
Like, what's the -a for?
So we can actually look, git -h, and this is a good idea to do. Like with Git, you have options in how you can get help with a command that you don't know. Meaning, so you can run something like git commit -h, and so that's just shorthand for git command or git commit -- help. So it's like Clippy popping up in Microsoft Office or something, or if you hit F1, it comes up with the help page. And so then this will print out a helpful page, like a manual for that. And then the other option is to just say man git commit. So then we can see git commit right here, and that this is the git manual. So this is the command we're looking at, and then we have all of these options. And honestly, it's kind of confusing how many options there are, or even how many possible commands there are. But the main ones that, the main one that you need to know are this -a, which Lisi asked about, and then this -m right here. So we talked about -m, that gets you your message. And then -a, we can scroll down a little bit. Alright. So the content can be added, or can be specified in several ways. Meaning, we can add the files one by one like we did with to-do, like git add to-do, and that adds it to the repository. Or, we can see here, by using the -a, we automatically add those files in. So anything that's in there or that's changed since our last commit, when we do -am, then all of those changes are going to be in this commit without having to take the extra step of git add. So what does that look like? Let's say we have our file in here, and we want to make some change. Like let's say, like we have some new topic to talk about. And then this is another program called Bin, which just helps you to edit files. And when you want to save, you do W, and then quit is Q. W for write, Q for quit. So then now, when we run git status again, we can see that we have this modified file called to-do. If we wanted to commit that change, we could either do git add and then to-do, and then another command git commit -m to specify the message. Or we can just say git commit -a. So the A says, oh, this to-do file changed. So include it in this commit, meaning add it just in the background. And then the -m, we specify our message again. So we can say new topic. And so you see, even though we didn't run git add, it says one file changed, 2 insertions. And then those 2 insertions are just like the changes we made when we edited the to-do file. Does that answer your question? Okay. So, let's see here. All right, there's help. And then as like an introductory page, if all you wanted to do was read the manual, you can run git help. And so this gives you the most commonly used git commands. Add, bisect, we don't have to look at right now. Branch, we talked about. We will talk about checkout and clone. Talked about commit. Yeah, so there are a good amount. And you can always get this list by running git help. So you don't have to worry about copying it down right now. So we can go on. Now let's try making a branch. So a branch is going to be when we branch off of master and we start making our own changes. In other words, commits we make on this new branch aren't going to impact the commits we make on the master branch. So you can say git branch, what's the name? Something we should call this. Alright, yeah, we'll do new branch. But we're still on master here. So in order to change branches, we can run this command called git checkout. So checkout, you can either give it those unique identifier numbers for each commit. And so if you say git checkout random super long number, and you'll go back to that. Or you can check out a different branch. So we can say git checkout new branch. And then, just so we see here, we are still in the Git repository, and now we're on the new branch. And if you wanted to see a list of all of the branches, you can just say git branch. And so if we have more, we have the master branch, which we already knew about, and then the new branch that we just created and switched to. So now, if we make more changes to our to-do file, and it's still there because nothing has changed yet. Let's say a new topic on a different branch. Now we can see with git status again that we've modified our file. But if, let's say we do go back to the master branch just to see if that change is still there. Git checkout master, and then so now the change is still in here because we never committed that change. It's like we edited the file but didn't tell Git that the file actually changed. And we didn't actually put that into any snapshot of our directory. So let's go back here. Now we're on the new branch again. And we'll do that -a flag again so we don't have to take the extra step of adding the file. It's on a different branch. Okay. So now on this new branch we committed that change. And if we go back to our old branch, and now we do a cat to do, we can see that we no longer have that one file change that we made. Because, and so do you guys know why? Or do you still have questions about it?
It's on the other branch.
Yeah, exactly. So then we could make a bunch of changes on those other branch, or on that other branch, or multiple other branches. And then we just end up with like a more complicated figure over here with, we could have branching off of this, merging into here, and so on. And so you just keep a list of changes that have been made. Okay, but now that we've made that change, let's say we're done with that feature. It was some complicated thing, something more than like adding it or adding a line to a file. We run this command called git merge. And so what merge does is it takes the name of the branch that you want to merge into this branch. Just kind of a dense way of saying, take all of those changes we made in new branch and then put them all into our master branch. So what that would look like is git merge new branch. So we can run that, and then we say, all right, updating this commit, this is our unique identifier, and then we update it to this one, this commit. And then something else, it's a fast forward commit, meaning we didn't do any real complicated changes, and we didn't have to spend time to merge everything together. Because if two people change the file at the same time, then it's whose changes are more important, and you have to make sure the program still works. So what Git does is, instead of a fast forward, it'll say files need to be finished merging or something like that. And it'll say conflicts need to be resolved. So then all you do is open those files that it says have issues, and you fix those, fix the issues that are there, make sure your program works, and then you can do another commit, and it will just work.
What happens if on master you have a file and on branch you have a file and you both have working features of a program, let's say, right? Like you have different functions,
Okay.
but each function there's different things that you change that you still want to be in the alternate function. Then how do you resolve those conflicts?
Okay, so this is where it can get a little bit hairy, because your program may change a lot on a different branch. So then when you try and add it back in, maybe that breaks things that are on the other, master branch. So it takes some discretion, I would say, or unique case-by-case changes. But we can, but Git will do its best to try and avoid any conflicts and just merge them automatically. And it's pretty good at it, but there are still some times where it doesn't work as well as it would. So that doesn't really answer your question, but it really just depends on the changes that you've made and how you can combine all of, like, the functionality of each branch into one program.
Also, another question, can you like, instead of merging all the branches into the master branch, or master, can you just like merge two branches, like two individual branches, and not touch master at all?
Yes. Which we can do that now if you want, just as an example. So, like, what that would look like is here, we create another branch like this. Here, and we have our own commit, and we can make some. And then instead of merging into branch or master, we can just merge into new branch. And so then you would be inside of new branch, and you call merge on this other branch.
So your location matters when you call a merge?
Yes. Any other questions? Or is this confusing? Okay. So let's see if there's anything else. Check out merge. So does anyone have any questions about these commands or any of the others I showed? Okay. And if you ever do, you can do git help, whatever the command is. And it will give you a sometimes too complicated, too lengthy discussion. And if so, the help pages online are pretty helpful. Just if you wanted to look at those. We can look at the git commit documentation. And so it's kind of a prettier website, and you get a like similar things or questions people have asked about those commands. So this git-scm.com website is helpful for that. And if you ever have a question or you can't Google around and find the answer, you can always email me, and I'll give you my email after the class. Alright, so now let's talk about github.com. So GitHub, when you create an account, let's log out of mine. You go to the website and it looks like this. So GitHub is, in a nutshell, a social network for programmers, meaning you create an account and then you can follow other people, and then you see all of the public commits that they make, and you can say, oh, that's really cool, or I want to try and work on this project, like this open source project. And so you can see some of those projects by going to this Explore page, and they categorize them nicely for you. Like if you wanted to see like open source organizations, let's say, which we'll look at after. Or there's also this trending this week or month, and you can see these popular projects that people started on their own or as a part of a team, and then it became popular basically on this social network. And then the benefit is that through using Git, all of those random people can contribute to these projects. So even though I've never talked to this Josh data person, I could, if I wanted to, mail in a box and contribute to this repository, to this project. But let's see. Let's sign in. Do my account. Two-factor authentication. Give me 1 sec. Okay, so let's look at this mail in a box right here. And there are a few things we can do when we're on this page. For one, we can see like this repository, okay, and it's called mail in a box. It's owned by this user, Josh Data, right here. And then we have these other options that are watch, star, and fork. Watch means every time there's a commit to this repository, it'll pop up on like our news feed or and then you can say, or you can see all of those changes, and if you want to contribute to it, then, and you see something that interests you, then you can go check it out and look at it and maybe help out with it. There's this star option, which star is kind of like favoriting the repo. Like you want to be able to find it later, so you star it now. And then when you look at your own, you can see that like you have starred repositories right here. So I have like 3 followers, I'm following 4 people, and I have 10 starred repositories, which you can see like here. But if you go back to this, and then, so the last option is to fork a repository. So fork is a little different than things we talked about before. Fork, if you want. But what it does is it creates a copy of this repository, but under your username. So then you can make whatever changes you want to that repository because you own it, it's yours. And then once you've made those changes, you can come back to the original repo and you can submit what's called a pull request. Now, it's kind of a lot of vocabulary, but what a pull request is you basically ask to merge all of the changes that you've made on your version of it and merge them all into this original one. So it's like, let's say, yeah, all right. So then I'll talk about that a little more. Yeah. Okay. So we can also explore all of the code that's in the repository, which is pretty self-explanatory. We can see all of the folders and files that are in them. We can check if there's more than one branch on this, but no, this one only has the master branch. And then we look, we can see all of the commits that have happened. So these are all of the messages that people have written after like the -m flag. And the timestamp, and then we have the number over here, which is the unique identifier of this commit. So then you can copy that number and then run git checkout, and then you'll have those changes. But we don't have to worry about that right now. So let's just do, let's make a repository for the cSplash directory that we were doing before. Yeah.
So if you like want to make a new repo, but like just make like a new folder, and then you make a file, and then you push the file,
Yeah.
do they automatically convert that folder into a repo?
Yes. So, so you mean we have this, like we have a repo right here in the cSplash directory, and then if we create a repo on GitHub, and then we push this to GitHub, does it automatically create?
No, okay, so if you like mkdir, you just like make a new directory on the new like Linux, right?
Yeah.
And like just like make a folder, and then like inside the folder you make a file, and then you push the file with Git. Does that make the directory automatic?
Oh, yes. So basically, the only folder that you call a repo is the top level folder. Because that's the only one that has this .git directory inside it. So if we do like, we make a folder, and you can see that right here, and then we make a file in there. And then if we go back to the original one and run git status, it doesn't automatically look at that folder, or at the file we made in our brand new folder, because it hasn't even looked inside of the folder yet. So if we do git add folder, and then git status again, we can see we have this new file inside. And then all right, and there we go, and we can make the change. But now, so if we go back to GitHub and we say create a new repository, we can give it a name, and I'll call it cSplash. Don't need a description. It can be public because anyone can see it. And then initialize this repository with a README. That's basically saying it'll create a file in there for you, which you can do, but for this one we won't. And then there's something called a git ignore file, meaning anything that's in this git ignore file, which is like in this top level directory right here, or any of the subdirectories, any file that's listed in there will just be ignored by Git, and any changes you make won't be committed. So the benefit of that is if you have like a logging file or something that changes really frequently, or maybe an executable program or something, or if you have like secret passwords or something like that, then you can just ignore those, and then even though your repository is public, no one will ever see those keys. So it's useful there. But we won't have any. So let's create the repository. And then we can see we're inside it right here. And quick setup, if you've done this kind of thing before. Okay. But here we see create a new repository on the command line. And we create a new file, which is what this touch command does. It's a new empty file, has nothing in it. We run the git init command, which we talked about. Creates this .git directory right here. We add readme, and then we commit and say first commit. And we did both of those. And if you wanted to combine these into one command, then that's when you add the -am instead of the -m. And then you could just get rid of this command right here. And then now is where we get to this command we haven't seen before, git remote add origin. So we've seen the git add before. So now instead of adding a file, we're just going to add this like website to our repository, and then we can push those changes to the repository. So we're saying git add, and then we have an option remote right here, which means it's this website or some other computer that we're adding. And then origin means where are the files coming from? Like this is going to be our like the repository that we push to. Like these are going to be the changes that when we say git push, they get sent here, and then anyone can see them. And then we say this right here, which is how we reference this website and add it in this command. So we can say like git remote add origin, and then we want just copy and paste this right here. And then when we run this, can you see it? So then when you run this, it doesn't tell you anything back. But if we look here, we can say git push -u origin master. So git push is going to take the repository we have on our computer and all of the current snapshots and everything we've saved and push it all to this website. And then for us, it's going to look similar to the mail in a box repo that we looked at earlier. And then the -u flag is an option to set upstream, meaning after this one time we do the -u origin master, we won't have to type that again, and we can just say git push. So git push -u origin master. All right, so then now we get more feedback from this. Counting objects 13, that's how many files and directories are in this folder. Delta compression using up to 4 threads is going to try and shrink everything down, like zip it, just so it's easier to send. And so that's the compressing. Writing means it's sending it over the network to github.com. And you can see new branch, okay, and we're sending master to master. And then this confusing sentence, branch master set up to track remote branch master from origin. Basically what that means is master on our computer right here is going to look at GitHub for its master branch because it's different, like it's a different computer, and then from origin is the from GitHub. So now let's look back here. If we refresh, we can see that we now have our repository and the nice user interface that GitHub gives us. And we can see the folder we made, the one file in it. We can have a list of all of the commands that we've run. Okay, so anyone have any questions about that? Yeah. All right. So I think that's probably a good place to stop. I can quickly demonstrate forking a repository if you want. Or there's also a GitHub help page that tells you. So, question? Okay. So you can either run through this, or I can do it really quickly right now. But we only have 4 minutes.
Can I ask a question about something weird that we over?
Yeah.
Like what happens when you clone a directory?
Okay, so.
Like I know how to clone one, but it's like always really complicated to clone it, which is really annoying.
Alright, let's say we don't have our cSplash directory anymore. Meaning, let's just go here, code, cSplash, and we delete it. So maybe that's because our computer crashed and we lost our hard drive. Maybe it was just an accident or something, or I don't know. But now we look and we say, oh no, I don't have my cSplash directory anymore. So what we can do is say git clone, and this is going to go to whatever website we tell it, in this case, this website. And can you see that? It'll go to this website and it'll clone that repository, meaning it'll clone this cSplash.git repository. So we run that and it says like receiving objects instead of sending objects. And then we look again and now we have this cSplash directory with all of the files that we've made, the folder we made, all of the changes we've made, and so we can see everything about this repository that we can see on the website. So all clone does is it takes a repository that's on a remote computer and copies it onto your own computer. So then once you do that, you can make changes on your own computer, and then you push those changes out to the remote again. But then if you have other people that are working on that same repository, then like let's say alright, so let's say we're on somebody else's, like I ran git clone for this wiki sort repository. But then if you want to make sure you have the most up-to-date version, meaning the version on github.com, then you run this git pull command. So that'll take all of the changes that were there and pull them down. Or if you already have them all, then it'll say already up to date. And then I think we're out of time. So any last minute questions?